right, like I said, we're skipping the do now, and the new lesson starts after the squiggly line. And the first question is asking us, or is telling us angle C is an acute angle. And then we're asked, what are the restrictions on the measure of angle C? So I will tell you this. Anytime I ask you for restrictions, you need two numbers. You need a number it is less than and a number it is greater than, always. Anytime I ask you for restrictions, you need two answers. You need a number it's less than and a number that it's greater than. So when I ask you the restrictions on angle C, well, didn't I tell you that angle C was an acute angle? So because it's an acute angle, it has its natural restrictions. What are the natural restrictions on an acute angle? I forgot. Victoria.
The restrictions are that the measure can't be more than 90 degrees, it has to be more than 0.
Excellent. So remember, I said we need two answers. Something it's bigger than, something it's less than. The way we're going to write this is you put whatever is going to have the restrictions in the middle. What's having the restrictions? The measure of angle C. And whatever it is less, or whatever it has to be less than, will go to the right. So less than 90. And then whatever it's greater than will go to the left. It has to be greater than 0. So this is how you write the restrictions all together. The crocodile always eats the bigger number, right? In inequalities, crocodile eats the bigger number. So C has to be bigger than 0. That's why the crocodile is eating this angle C, or the measure of angle C. And then that measure of angle C has to be less than 90. 90 is bigger than the measure of angle C, so that's why the crocodile is eating the 90 there. And that's how you write the restriction all together. Now I'm going to take this a step further. Now it's saying, what are the restrictions on X? All right, well, look at your diagram. Didn't I show you that angle, or I represented that angle C was represented by 2x plus 14? So now we're going to go into that inequality we just wrote. But instead of the measure of angle C, I'm now going to substitute in the variable expression for it. So it's going to be, let's go with black. 0 is less than 2x plus 14, which is less than 90. And now we solve this. Now the way we solve this, I'm going to show you how we could solve this all in one shot. It's sort of just like solving an equation with two equal signs. So let's just ignore that this part was here. If this was 2x plus 14 equals 90, where would you start in solving this?
Subtract 14 on both sides.
Good. You would start by, we need to isolate the x, right? So we would subtract 14. We're going to do the same thing, but now we're going to subtract 14 under everything. So I'm going to subtract 14 under the 14, under the 90, and also under the 0, under everything. So now we'll have negative 14 is less than 2x, which is less than 76. Yeah? All right, ignore this side. What would you have to do now if we were solving for x? Lucas? Divide by 2. So now I'm going to divide by 2 under everything. I'm going to divide by 2 under the 2x, divide by 2 under the 72, and divide by 2 under the negative 14. So now we will have negative 7, not negative 7, positive 7 is less than x, which is less than 38. Oh, not 38. It's supposed to be 38. This isn't 72. This is 76. Nobody caught that? Somebody caught it and didn't say something? Yeah? So then it will be 38. Yes, Sean?
Why do we divide negative 14 by negative 2?
Why? Did you understand why we subtracted the 14?
Yeah.
Okay, so ignore the 90. If it was just 0 equals 2x plus 14, right? You would subtract the 14, and then wouldn't you have to divide by 2?
Found this on the web.
No, why is it divided by -2?
Oh, it's not. I'm so sorry. Why did I do that? I don't know. Thanks, Sean. So this is -7 then. Am I good everywhere else?
Yes.
Okay. Sorry. And that is your restrictions on X. All right, parts of a degree. So we know our degrees, like when you have a protractor, you're measuring an angle, we all know about them. We also know there's allowed to have we're allowed to have fractional parts of a degree, right? You could have 21.5, you could have 21 1/4 degree. You're allowed to have fractional parts of a degree. But to be a little bit more accurate, what we've done is now we've split the degrees into a smaller frame. We've now said, okay, well, we can take the degrees and split it into minutes, and we could take minutes and split it into seconds. So the correlation here is that 1 degree is equal to 60 minutes. And 1 minute is equal to 60 seconds. And there's symbols for degrees, minutes, and seconds. We all know the little circle in the top corner represents degree. Right? That's a degree. 1 slash by the number represents minutes, and 2 slashes represents seconds. So now how are we going to use this? Let me show you. We want to convert to degrees and minutes. So I'm going to take 87.5 degrees. I want to change it to degrees and minutes. I want us to take the whole number. In 87.5 degrees, which number is the whole number? 87. You're going to take that 87, you're going to keep that as your degrees. And now you're going to change the fraction to minutes. We know 1 degree is equal to 60 minutes. Do we all agree on that? So if 1 degree is 60 minutes, what's half a degree? 30 minutes. You got it. So this is 87 degrees and 30 minutes. Do you think they'll all be that easy? No. All right, so let's step it up a bit. So in number 2, we have 60.4 degrees. I'm going to start off the same way. I'm going to take my whole number. What is my whole number? 60. Keep your 60. And then I'm going to take the fractional part. The fractional part is the 0.4. Do we agree that 0.4 is the same as 4 over 10?
Yes.
And what is 4 over 10 reduced to? 2/5. So now this represents 2/5 of a degree. Do you agree that's what 0.4 is, 2/5 of a degree? So the way we're going to do this is you're going to take the fractional part, 2/5. The word of goes with what operation? What mathematical operation goes with the word of? Yes, mathematical operation. Only 2 people know. Somebody take a guess. What mathematical operation goes with the word of? I'd rather you be wrong than not try at all. Ephrapitus. Multiplication, you got it. The word of goes with multiplication. So what you're going to do every time here is you're going to take the fraction and you're going to multiply it, and it's 2/5 of a degree. Well, a degree is how many minutes? 60. So you're going to multiply it by 60. I'll make it into a fraction by going 60 over 1. Now, what is the great thing that we can do when we are multiplying fractions? Alexa?
Cross simplify.
Excellent. Cross simplify. 5 goes into 60 12 times. So what are we left with? 2 times 12, which is 24. So it's 24 minutes. 60 degrees and 24 minutes. So to wrap this up, what do? Take the fractional part, multiply it by 60. Take the fractional part, multiply it by 60. That will give you your minutes. All right. What's different with number 3? Victoria?
It doesn't have a fraction.
Perfect. It doesn't have a fraction. That doesn't mean we can't do this problem. It means we're going to have to be a little bit creative here. So watch what I'm going to do. Without changing the value, I'm going to take that 90 and I'm going to say, well, 90 degrees is the same as 89 degrees plus 1 degree. Do we agree on that? I haven't changed the value. 90 is 89 plus 1. I'm going to keep the bigger number. What is the bigger number? 89. That's going to stay as my degrees. Then I'm going to take that 1 degree and I'm going to change it to minutes. 1 degree is how many minutes? 60. So it's 89 degrees and 60 minutes. It's still 90. Still 90. Yes?
Why couldn't you have just left that 90 degrees?
Because I said write everything with degrees and minutes. So we had to. And you'll see later on in the lesson why in some problems we would have to know how to do this. I want you all to try number 4 on your own. Try number 4 on your own. Again, you're taking that 180 and changing it to degrees and minutes. No Lauren today? All right, what did we get? What did you get? Same hands every time. Tim.
179 degrees and 60 minutes.
Perfect. Who wants to see me do it? Good. How many people got that? Good job. All right, so now I'm going to take it a step further. So now I don't only want us to convert to degrees and minutes. Now I want us to convert into degrees, minutes, and seconds. Watch how I'm going to do number 5. We're going to take that 90. We're going to take that 90 and I'm going to split it just like I did before. I'm going to split this into 89 plus 1 degree. I'm not going to make it 88. Not making it 88. I'm making it 89 plus 1 degree. And I'm going to do exactly what I did before. I'm going to take that 89, leave it as my degrees, and I'm going to take that 1 degree, and guess what I'm going to change it to? 60 minutes. Is this the format it was asked to be given in? No, we want degrees, minutes, and seconds. So now I need seconds. I'm not going back to my degrees. I'm not taking away a degree. I've already done that. I'm now going to go to my minutes. And instead of 60 minutes, guess what I'm going to do? 89 degrees, 59 minutes plus 1 minute. And that 1 minute is worth how many seconds? 60 seconds. So this is 89 degrees, 59 minutes, 60 seconds. All right, this next one's going to be a bit of a doozy. It's involved. So we're going back to having a fractional part. So when we were dealing with a degree that's a whole number and a fraction, what did I tell you to do? We're going to keep what? Keep the whole number. So we're going to keep our whole number as 12 degrees. And then we're going to take the fractional part and multiply it by what number? 60. You're going to take your fractional part, you're going to multiply it by 60. Now, this is where you can tell that there's going to be a hiccup here. Does 9 go into 60 evenly? No, but is there a number that goes into 9 and 60 evenly? 3, right? 3 goes into 9 3 times, 3 goes into 60 20 times. So now we're left with 40 over 3. Does 3 go into 40 evenly? No. So now I need you to change this into a mixed number. Change to a mixed number. So 40 divided by 3. Excellent. Does anybody, don't be shy, does anybody need to see me do the division here? Okay, so we should get 13 and 1/3. So now we're going to have 13 and 1/3 minutes. We're going to do that whole process again. I'm going to keep the whole number. What's the whole number? 13. So that goes into my minutes. It's 13 minutes. And then I'm going to take the fraction, and what am I going to do with the fraction? Multiply it by 60. 3 goes into 60 20 times. So what does that mean? It is 20 seconds. You got it. So moral of the story, keep taking the fraction and multiplying it by 60. Take the fraction, multiply by 60. If there's another fraction, take it, multiply it by 60. All right, so now we're going to go the other direction. Now I'm giving you degrees and minutes, and I want you to change it only into degrees. This is actually a lot easier going back when I give it to you. So 42 degrees and 12 minutes. Well, again, you're going to keep your whole number or your degrees. You're going to keep your degrees of 42. Then you're going to take your minutes. That is 12 minutes out of how many minutes? 60. So you put it as a fraction. You put the minutes over 60. And then you simplify. Divide by 12. Divide by 12. We get 1/5. So this is 42 and 1/5. I want you all to do number 8 on your own. All right, who has an answer for me? Julia? You got it, 60 and 3/4 degrees. Anybody want to see me do it? Okay. All right, so now let's see how this comes into play. So I keep saying this, and I'm going to keep on saying it. In order to be successful in geometry, you need to know how to read your given information, understand your given information, but also label your diagram with the given information. You will not be successful if you are not labeling your diagrams. So it's telling us angle ABC is a right angle. How do I mark a right angle in a diagram? A little square, you got it. So ABC, there's our angle, is a right angle. Then they're telling us, follow the letters, angle ABD. So you're going from A to B to D. That's that top angle of the 90-degree angle. They're telling us that is 67 degrees, 21 minutes, and 37 seconds. And we're being asked to find angle DBC. So from D to B to C. We're asked to find that lower angle. Are we caught up? All right, so let's talk about this. Let's forget about this whole mess. 67, 21, 37, forget it's there. If I told you the big angle was 90 and I told you the top angle was 60, what is the bottom angle? 30, how'd you know? What'd you do? Subtraction, 90 minus the top angle, right? It's the same idea. I'm telling you the whole angle is 90. I'm telling you the top angle is this whole ugly thing. We're going to subtract. So we're going to take 90 and subtract from that 67 degrees, 21 minutes, and 37 seconds. Well, now we hit a little bump in the road. What's the little bump in the road, Sean?
There are no minutes and seconds for 90.
Good. They're in different formats. The 90 is just in degrees, and the bottom angle's in degrees, minutes, and seconds. You can't subtract them if they're not in the same format. So we have options. We could either change the 90 into minutes, degrees, minutes, and seconds, or change this whole thing and try to make it just degrees, which is never do that. Don't ever do that. That won't work well for you. So really our only option here is to take the 90 and change it into degrees, minutes, and seconds. Didn't we practice that on the other page? So take that 90, we're going to split it down into 89 degrees and how many minutes? Well, we'll go phases, you're right. So 60 minutes, but then we're going to take that 60 minutes and we're going to change that into 89 degrees and 59 minutes and how many seconds? 60. Did I go too fast? Did I lose anybody? A little bit? Yeah? Okay, let's go back. I want you to tell me to slow down or go back, or how did you do that, Miss Abdelbar? Don't be scared. All right, so breaking it down, 90 is the same as 89 degrees plus 1 degree, right? So now we're going to take that 1 degree and we're going to make it into 60 minutes. All right, but now we don't only want degrees and minutes. What do we want? We want degrees, minutes, and seconds. So now I'm going to keep that 89 the way it is. I'm going to take that 60 minutes and I'm going to change it into 59 minutes plus 1 minute. So it's still 60. I'm not changing the value, but then I'm going to take that 1 minute and change it into 60 seconds. Better? All right, so now that we have it all laid out properly, now we can subtract 89 degrees, 59 minutes, 60 seconds, minus 67 degrees, 21 minutes, 37 seconds. And then we subtract within the same unit, you can easily borrow. So I'm going to take from the 6, make that a 5, make that a 10. 10 minus 7 is 3. 5 minus 3 is 2. 59 minus 21 is a 38. 89 minus 67 is 22. So what is the measure of angle DBC? It is 22 degrees, 38 minutes, and 23 seconds. Alexander, now you see why we were practicing that? All right, number 10. Bear with me on number 10. I'm going to rewrite it. We have 61 degrees and 15 minutes minus 40 degrees and 26 minutes. Right away, there's a problem. What is the problem right away? Only 2 people see a problem. Dylan?
You can't subtract 15 from 26.
Or 26 from 15, right? I cannot take 26 away from 15. 15 is small, 26 is big. We can't do that. So we're going to need to borrow. But where do we need to borrow from? We're going to need to borrow from the degrees because these are 2 different measurements, right? Minutes and degrees. So I'm going to go and I'm going to borrow 1 degree. When I borrow 1 degree, that becomes 60. No problem there, right? That's okay. But now when I go back to the minutes, I'm not adding 1 minute. I'm adding 1 degree, which is 60 minutes. Exactly. I'm adding a 60 here. So this becomes 60 degrees, 75 minutes, and then we can subtract 40 degrees and 26 minutes. And now we can take 26 from 75. And borrowing within the same measurement is good. So this becomes a 6, this becomes a 15. 15 minus 6 is 9. 6 minus 2 is 4. 60 minus 40 is 20. So we are at 20 degrees and 49 minutes. Are we ready for the next one? All right, the word congruent. You are going to hear the word congruent from this point on for the rest of the year. Congruent means basically the same. So if we have 2 segments that are congruent, that means they have the same length. If we have 2 angles that are congruent, that means they have the same degree measure. If we have 2 shapes that are congruent, that means they're the same shape and the same size. Okay? That's what congruent means. It means they're the same. So congruent angles that have the same measure, congruent segments are segments that have the same length. The symbol for congruent is, you're going to draw an equal sign with a squiggly over it, John. Equal sign with a squiggly over it. Identical tick marks are used to indicate congruent angles and segments. So let me show you. Do you see how in these 2 triangles, my angle K has a loop with a slash through it, and my angle T has a loop with a slash through it? They have the same tick mark. That's what it's called, same tick mark. Because they have the same tick mark, that's how we show that they're congruent. So that means we can say angle K is congruent to angle T. And that's how we would write it, angle K congruent to angle T. Just looking at the triangles, forget about that trapezoid right now, just looking at the triangles, does anybody see any segments that would be congruent based on the tick marks? Any segments that are congruent based on the tick marks? Only Victoria? Nobody else? Alexander?
SR and HG.
Excellent. If you see SR has 1 slash and GH has 1 slash, that means they're congruent. So the way we write that is we're going to say segment SR, congruent symbol, segment GH. Looking at the 2 triangles, anything else have the same tick marks? No. Looking at the 2 triangles, nothing else has the same tick marks. So we're done with the triangles. Go to the trapezoid looking shape now. Can anybody name anything congruent in the trapezoid? John.
Line segment CW and line segment YX.
You got it. Segment ZW and segment YX. Anybody see any angles that are congruent based on the tick marks? Cameron.
Angle W, angle X.
You got it. Angle W is congruent to angle X. We're actually going to just stop here, and then we'll finish up this lesson tomorrow. We're going to stop here. We'll finish up the lesson tomorrow.